Hello everyone, welcome back to my channel. So in this video we are going to learn about narrow band, the first type of FM modulation scheme, that is narrow band FM. Okay, so in short we'll call it as NBFM, for which beta value is less than 1. Okay, so this is the concept which we are going to learn now. If you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So narrowband FM. So NBFM is given by beta, for which beta is less than 1. So what is the standard time domain equation, single tone FM? So in the previous video I have derived the formula for this single tone FM. So if you have not seen that video, I'll give that link in the description, the playlist link in the description. So go there and see all the videos, then you will come back, here and understand this concept. So S of t of single tone FM is given by AC into cos of 2 pi fc into t plus beta sine 2 pi fm into t. Okay, so this is the standard time domain equation of single tone FM, where beta represents the modulation index. Beta represents the modulation index in FM. Okay, given by the formula beta is equal to kf into am by fm is equal to delta f by fm. Okay, where FM represents the frequency of message, AM represents amplitude of the message, and KF represents the frequency sensitivity of the modulator. Okay, so all this you have to remember, right? Now see, this is of the form cos of A plus B. Okay, so I'm taking this total term as A and this term as B and expanding that cos of A plus B, that is cos A cos B minus sin A sin B. So AC into, so AC is multiplied for both the terms, AC into cos A. Cos A is cos 2 pi fct into cos of beta sine 2 pi fm into t, minus AC will be there here also into sin A. Sin A is sin 2 pi fct, cos A cos B minus sin A sin B. Sin B is sin of beta into sin 2 pi fm into t. Okay, so now we will consider something. So here when theta is very much less than 1, then cos theta is nearly equal to 1 and sin theta is nearly equal to theta. When theta value is very much less than 1, so cos theta is nearly equal to cos, like if you take 0, cos 0 is nearly equal to 1 and sin 0 is nearly equal to 0. Okay, so because theta less than 1 means we can take the 0 value also. So this is the thing here. So here also when you apply this concept in this equation, now we are finding for NBFM. So from the next step I am finding for NBFM. Okay, so if for narrow band frequency, what is the consideration? So beta value is less than 1. When beta value is less than 1, what can we take is cos of beta sine 2 pi fm into t, that is this term. This term is nearly equal to 1 and sine of beta sine 2 pi fm into t. So sin theta is nearly equal to theta, so I am taking it as beta sine 2 pi fm into t. So sine of beta sine 2 pi fm t is almost equal to beta sine 2 pi fm t, that is sin theta is equal to theta and cos theta is equal to 1 because beta is less than 1, and this is from trigonometry concepts only. Okay, so I'm substituting this value, and when you substitute that, this is applicable only for NBFM, so we'll get the time domain equation of NBFM here. Understood? Right. See here, so AC into cos of 2 pi fct I'm taking, and this value is equal to 1, so multiplied by 1 doesn't make any difference, so I'm taking like that. So minus is there here, and so I'm writing minus here. AC into sine 2 pi fct, I'm writing as it is. So sine theta I'm replacing with theta, so I'm writing it with beta sine 2 pi fm into t. Okay, so this is what the changes you have to make when you want to write the time domain equation of NBFM wave. So s of t of NBFM is given by, so first term is same, AC cos of 2 pi fct. So this is of the form 2 sine sine, right? So A minus AC beta by 2, I'm dividing it with 2 and multiplying with 2 sine 2 pi fct into sine 2 pi fm into t. Okay, so what can we write here? 2 sine sine form. So 2 sine sine form is cos of a plus b, sorry, cos of a minus b minus cos of a plus b. So cos AC cos of 2 pi fct minus AC beta by 2 into now tell me, so cos of a minus b first, so cos 2 pi into fc minus fm into t, cos of a minus b minus cos of a plus b, cos 2 pi into fc plus fm into t. Okay, so this is a and this is, sorry, this is a and this is b, cos of a minus b first minus cos of a plus b. So if you take outside, so standard time domain equation of NBFM is given by AC cos of 2 pi fct. Okay, so plus, I'm taking the upper side band first, so minus into minus becomes plus here, plus AC beta by 2 into cos 2 pi fc plus fm into t minus, so minus into plus becomes minus AC beta by 2 into, sorry, AC beta by 2 into cos 2 pi fc minus fm into t. Okay, so this is the standard time domain equation of NBFM signal. Okay, so you have to remember this. So now we have seen the standard time domain equation of NBFM signal. Narrow band frequency modulated signal is given by AC cos of 2 pi fct plus AC beta by 2 cos of 2 pi into fc plus fm into t minus AC beta by 2 cos of 2 pi into fc minus fm into t. Okay, so this is same as AM, yes or no? So in the AM concept also we have seen S of t of AM for single tone AM. So its formula is given by S of t is equal to AC cos 2 pi fct plus AC mu by 2 cos 2 pi. So mu is called as modulation index in AM, fc plus fm into t plus AC mu by 2 cos 2 pi into fc minus fm into t. Okay, so both are looking same, yes or no? So what is the important point here is, so this point is asked in many competitive exams. So the difference between NBFM narrow band frequency modulated signal and amplitude modulated signal, NBFM and AM signals, is in NBFM lower side band is out of phase, is 180 degrees out of phase. So this is only carrier term. Okay, so this is only carrier term and this is upper side band and this is lower side band. Similarly this is lower side band in the case of AM signal. Okay, so here you have a negative sign here. So negative sign represents, negative amplitude represents 180 degrees phase shift. So this we already know. So a negative amplitude always represents a 180 degrees phase shift. So The difference between NBFM and AM signal is in NBFM. So in NBFM, the LSB term is 180 degrees out of phase, and USB term having the same sign here, and carrier is same also. So only change is with respect to LSB, and that LSB is 180 degrees out of phase. Okay, so this is very important point which you have to remember. In NBFM, LSB is 180 degrees out of phase. Okay, so due to that out of phase, how will be the spectrum of NBFM signal? So the spectrum of NBFM signal, S of F of NBFM. So it will be same as single tone modulation of AM only. So due to AC cos 2 pi FCT, you have two impulses. One is at plus FC and other is at minus FC. Okay, so I'm not telling you all the remaining concepts because I have already discussed in AM. Okay, so when you have a cos term, you will get two impulses. One is at plus FC and one is at minus FC. So the amplitudes here are amplitude get divided by 2. So the maximum amplitude AC, so amplitude gets divided by 2. So the amplitude is AC by 2 in the spectrum. Okay, right. Now due to second term is USB, so you'll get again two impulses. One is at FC plus FM, other is at minus FC minus FM. Okay, so that is minus FC minus FM. So its impulse amplitude is again divided by 2. So actual amplitude is AC beta by 2. So now we will get AC beta by 4. Okay, so this is from the Fourier transform formula only, right? So LSB, so when you are drawing LSB, A in the AM, because it is not 180 degrees out of phase, you have drawn on the upper side only, upper side of this, that is it is a positive value, but now it is a negative amplitude. So the amplitude here is minus AC beta by 2. So amplitude here is minus AC beta by 2. That's why you have to draw downside. The impulse should be drawn downside because the impulse amplitude is negative. So one is at FC minus FM. Okay, so one impulse is at FC minus FM and other impulse is at minus FC plus FM. Okay, so here the amplitude is minus AC beta by 2. Okay, so only change is with respect to this LSB term. Okay, so that is the only difference between NBFM and AM, right? So since both are looking same in time domain equation also, both are looking same, so the total power in the case of NBFM, the total power in the case of NBFM is given by PC into 1 plus beta square by 2. So for AM we have got PT is equal to PC into 1 plus mu square by 2, where mu is the modulation index of AM. Similarly the NBFM PT is equal to PC into 1 plus beta square by 2. Because the amplitude is anyhow squared, for power we are taking VRMS whole square. So when you are taking square, even if it is negative, it becomes positive. So you'll get the same value for power. So PC into 1 plus beta square by 2. Again PC is equal to again AC square by 2. Okay, so you'll get the same form like this. And similarly bandwidth. So bandwidth is highest frequency. So highest frequency is FC plus FM and lowest frequency is FC minus FM. So FC plus FM minus FC minus FM. So it is again 2 FM. So bandwidth of NBFM signal is again equal to 2 FM. Okay, so this is the formulas for calculating power and bandwidth for an NBFM signal. Because why we have taken this? Because it is similar to AM. Okay, so this is the difference and similarities between AM and NBFM signal. So one important point which is asked in previous one of the previous exam is, if AM and NBFM signals, okay, so if AM and NBFM signals are with same modulation index, with same modulation index, with same modulation indices are added, then the resultant signal is what? So then resultant signal is dash. Okay, so what is the resultant signal he is asking? So when AM and NBFM signals are added here, so these two are added. When these two are added, that is with same modulation indices, means mu value is almost equal to beta value. So when mu is equal to beta, this term and this term gets cancelled out when these two are added, because this is minus and this is plus, and a mu value is almost equal to beta. So these two terms gets cancelled out, and the only term which is left over is what we have? Carrier with USB. So the resultant signal is carrier with USB. Carrier with USB, that is SSB signal. Carrier with USB, which is an SSB signal. Okay, so this is the important point which you have to remember. Okay.